the next couple slides that involve this Moon Jelly modeling tool. This is something that I would have taught in class, but with the 4-day weekend that we have, it kind of threw us off a little bit. So on slide number 9 on your slides, you're going to see this Moon Jelly modeling tool. Let's read through the text real quick. It says, this is an example of a modeling tool that can be used to represent a sample of the population. There are only 6 jellies represented in the sample, but there are millions of jellies in the real population. Scientists use models to easily represent what is happening on much larger scales. So again, this is just a model of the moon jelly population. This is a tool that scientists might use to help them study larger populations, and they use this at a smaller scale. There's a couple things I want to point out that are going to be necessary for you to use this tool. The first thing over here is the key. This key tells us that an organism in the population is represented by a square with a jelly inside of it. Looks like that. Whenever a jelly dies, we have a death, and that's represented by that red X. And whenever there's a birth in the population, that's represented by the gray box with a B inside of it. A couple things I want you to notice. The X's, they're always drawn over the existing jellies. And then the B's representing births, those are added in underneath. Looking at slide number 10, mine looks just a tiny bit different. I don't have the green box with the tools that you guys do, but let's look at this one together real quick. Question number 1 says, what can you say about this population? Is it increasing, decreasing, or remaining stable? So to answer that question, we have to look right over here at this modeling tool. Here I can see that we started with those original 6 jellies, 1, 2, 3, 4, 5, 6. But over time, we had 4 deaths, and I know that because there is 1 red X, 2, 3, 4 red X's, and we had 3 births, 1, 2, 3 of those gray B's. So I can actually kind of skip answering question number 1, and I can move on to 2 and 3. It says, how many births were there? There were 3 births. And how many deaths were there? There were 4 deaths. So since we have more deaths than births, 4 is bigger than 3, we can say that this population is decreasing. I'm going to skip a couple of these because you can do these on your own. Now I'm going to cruise down to, on your slides, this is number 13. This is the first time that it asks you to show a scenario and model it yourself. So this one asks you to model a scenario that shows the moon jelly population remaining stable. Now there's a lot of different ways that you can choose to model this, but when a population is stable, you have to keep in mind that the births are equal to the deaths. So one way that I could model this population, and on yours, you're able to drag and drop these symbols. I can't do that because I'm working with a PDF right now, but I'll go ahead and draw them in. I could say that 1 jelly died and that 1 jelly was born. There's a lot of other ways that you could model that exact same scenario, but that is one way to show that the population is stable. The last thing I want to talk about is on yours, this one is slide number 16, modeling based on the graph. Now I'm not going to go and model this for you. I want you to challenge yourself. But one thing I do want to point out is that when you're modeling this graph, you want to model the entire timeline. So I think some of you might get kind of hung up and you're like, I don't know if I should model it stabling or increasing, but I want you to model the change from point A over here to point B over here. So you're looking at the change over the entire graph, not just certain sections of it. If you have any questions, please feel free to send me an email or stop by tutoring, and I can help you out with this.